Hello everyone and welcome to my speech on breath holding. Now before we start the speech, I want everyone to, we're all going to do a little friendly competition. So I want everyone at home to maybe put up a timer or something and try to hold their breath for as long as they can. Now I don't want anyone to die, so I hope that when it's uncomfortable, just start breathing again and don't push it. But I want to see what you guys do. Alright, so to start, my inquiry question, or the starting question overall that I had for this topic is, can you increase the amount of time that you can hold your breath through training? And there's two sides. One is the genetic side where, oh no, it's only genetics and there's no way to increase the amount of time you can hold your breath. And the other side is the training side that says that, oh, you can train and you can do certain exercises that will help increase the amount of time you can hold your breath. Now, I really got into this when I was young and summer, pool, and I was challenging all my friends to hold their breath, and I would try to win. Sometimes I would win, but when I would lose, I would always blame it on, oh, he or she is better than me. Oh, they just were born that way. But now I can finally put that to rest and see, can I actually train myself to hold my breath longer? So first we're going to get into the genetic side of things. Now to start, we're going to talk about the sea nomads. And these people are relatives or people, or a family that can hold their breath and also hold your breath like 20 meters down for 13 minutes or more. And that was crazy to me when I first heard it. And I said, well, how can they do this? So actually, medical professionals came and pretty much examined their entire body for any irregularities, and they found that their spleens were bigger, about 15% bigger than the average human. Well, you might be thinking, Blake, well, what do spleens have to do with anything? Well, let me give you a little example here. So this is according to Thornton, 2004. So this is the spleen right here, and this tube goes to the lungs. And these little dots are oxygenated red blood cells. So, when the oxygenated red blood cells go in, they go in and they pump through the heart and they go to the rest of the body. Now, this is going to the spleen. Now, the spleen, it pretty much conserves these oxygenated red blood cells and keeps them for when there's an emergency. For example, when you are trapped somewhere underwater and you need them, they can outbursts and you can have a breath of fresh air, kind of. And then also in running, maybe you're out of breath and you're about to pass out, they like give you a little boost. Now, these nomads have a bigger one of these, so they can hold more red blood cells, oxygenated ones, in their spleens, which means that they can have that little boost, and then they can have a longer boost, which means that they can hold their breath longer. Now, moving on to the more deep sea diver sort of thing, the training side. There's many different forms of training. The two big ones are tables, and there's CO2 tables, and there's O2 tables, carbon dioxide tables, oxygen tables. And I will be discussing what tables are and the differences between the two. So first, tables. It's pretty much just an exercise for your lungs. So to start, these tables, it's about 6 different sets or workouts, and it's pretty much a certain amount of time you have to hold your breath, and then a certain amount of time that you're allotted to breathe, and then back and forth and back and forth. Now, CO2 tables. These tables really focus on building up the amount of CO2 that you have in your bloodstream and being okay with that and not being uncomfortable. And if you're uncomfortable, not letting it get to your mind. Now, these work by having the same amount of time you have to hold your breath, but a decreased amount of time that you get to breathe every single time. So, for example, let's start with the first set, 1 minute, and then the amount of time that you get to breathe is 1 minute. The second set would be the same amount of time you get to hold your breath, 1 minute, and then the time you get to breathe is 45 seconds. So it's pretty much just going down on the amount of time that you get to hold your breath, which is pretty much just building up more CO2 in your blood and accustoming you to that, supposedly. Now moving on to the O2 or oxygen tables. These tables help you keep calm under pressure when not having a lot of oxygen in your bloodstream. And this is pretty much the complete opposite of the other. So, pretend we have one here. The time that you're supposed to hold your breath would increase every time, and the amount that you're supposed to breathe is the same. So, for example, minute to hold, minute to breathe, a minute 15 to hold, a minute to breathe, and then it keeps on going, so on and so forth. Now, these were the big ones that me and my dad did for our experiments, for our alert, and they're the big ones that most people, most freedivers do. All right, and that was according to Freedive UK and McKay. Now, moving on to one small reflex that all of us have. It's called the diver's reflex, and all mammals use this, including otters, and otters take this to the next level. And it's pretty much when you're underwater, or when your face is fully submerged, or your nose is fully submerged in cold water, the nerves from your face pretty much just tell your body to slow your heart rate and constrict all of your blood, not all of it, but pretty much just prioritize like your blood to your main vital organs so you stay alive. And this is pretty much like an emergency mode. Like you flipped a switch in your body that says, oh, okay, we're on emergency and we need to pretty much just, we're not trying to make you comfortable, we're just trying to make you survive. So this can happen when you're diving deep down and you need to hold your breath longer. So the lower heart rate helps you hold your breath longer, and divers take advantage of this all the time. And that was according to Gajek. Sorry if I messed up his name. Alright, moving on to the last technique that is more, I guess you would say, advanced. It's called packing. And packing is pretty self-explanatory. It's where you pack more oxygen into your lungs. And it pretty much happens, and only extreme divers do this, so please don't try this at home. But it's where you hold your breath in, and then at the end, like when you think you have nothing left, you use your throat muscles, your cheek muscles, and your tongue muscles to pretty much swallow more air and just pack your lungs up as much as possible. So to give it, I don't want to embarrass myself, so I'm gonna let the professional do it. And this is a professional freediver, and he knows how to pack very well. And this is his pretty much tutorial on how to do it. And this is pretty much, I just want to show you guys how to do it. And my last little segment was from Freediving Freedom. Let's play this.
This is how it works. I breathe in all the air I can, and then I start taking very small breaths of air into my mouth and pushing it into my lungs. Some say you should use your tongue to do this, but personally I think it feels more like taking a lot of small breaths on top of my first breath. You can also try to breathe normally as much as you can, and then hold your breath for a minute. After a minute, you will see that you're able to breathe in even more. That is because your lungs are flexible, but use some time before they adjust. Doing careful packing exercises over a long period of time will expand your lung volume. If you're not experienced with holding your breath, you can get very tense and uncomfortable holding your breath with filled lungs. And it can feel...
Okay, so it kind of looks kind of weird, but it really helps divers. Almost 15% more air can fill your lungs, and that means 15% more time to spend on holding your breath.
Like it's easier to hold your...
Sorry about that. Alright, now moving on to the hypothesis and the experiment that I did with me and my dad. So, my hypothesis, after all of this background research and all of this researching and stuff like that, I concluded that I believe that training will increase the amount of time that you are able to breathe. Because I've seen all these people, these freedivers, claiming that they're getting so many miraculous results, so I'm just going to trust them. So, now to the experiment side of things. I used two people, me and my dad, to make it a little less biased on the experiment. And we both did tables, the CO2 and O2 tables. We did not do any packing or any sort of things like that because that was a little too dangerous. And we all did this on dry land. So this is my little graph. I'm going to show you guys that. So you guys can look at that and then I'll explain it. Okay. So now to start day one, we didn't do any training, and we just timed ourselves on how long we could hold our breath. So at the first, my dad got a time of 1 minute and 43 seconds, which is pretty good. It's very good for an average amount of time. And then me, I got 1 minute and 21 seconds, which is pretty good. It's average, a little on the higher side of the average, which I liked. So on day 2, I downloaded this app, and it's a swimming apnea app, and it pretty much it does those tables and times you. And after day 2, we both increased by around 9 seconds, more or less. And as the days went on, we went up and up and up. And it was a slow increase, and sometimes we plateaued out with the same number, but we kept on going. And as I went, I got on day 10 to 3 minutes and 22 seconds. And when I got this, I was freaking out. I was off the walls. Like, are you kidding me that I actually did this? And I was great. And my dad got a time of, on day 10, 2 minutes and 48 seconds. You might be thinking, well, how did you beat your dad? But he didn't get all of the times. He didn't practice as much as me. So that solidifies that this training actually worked, because I trained more than him, and I actually surpassed him in that. So, moving on to the overall theory, yes, training does, after my tests, we didn't have any extra things on the next days to help us increase our breath. No 100% O2. It was all completely fair, and now we can confirm that training does increase the amount of time you can hold your breath. So hopefully you held your breath a good amount of time, and if you guys can use these, you guys can use these techniques anytime you want, and I hope you learned something. And yeah, thank you.